Yeah, my topic is about machine learning and translation technology. And obviously our focus is on translation technology here. It goes without saying that translation technology plays an increasingly important role nowadays, given the fact that we have like some new developments in the field of translation, in the field of translation. So for example, we have a surging demand for translation, and at the same time, we have different new kinds of translation activities. So as you can see here on the screen, for example, we have kind of, in addition to document translation, we need to consider other forms of translation as well, from multimedia translation, video translation, to web localization, even game and software localization, bilingual communication, and so on. So we have different forms of bilingual activities, and also we need to deal with different subject matters as well, from literary translation to business translation, legal translation, and social media translation, and so on. So given the fact that we have kind of new and emerging forms of translation activities, translation technology can be very helpful from the perspective of like ways to increase or enhance the effectiveness and efficiency of translation. So for example, translation technology like translation memory can help reduce the need of translating repetitive expressions, and we can reuse what has already been translated before. And in addition to that, sometimes translation technology can help translators make informed decisions, providing kind of useful suggestions, translation drafts, and so on. So it's really useful for us to make good use of translation technology in order to increase the speed and quality of translation. So I'm so happy to have the opportunity to be here to talk about translation technology. This is a really important topic nowadays. So thank you for your kind invitation as well, Professor Chen and Professor Zhang. Okay, so I would like to say a few words about machine learning, because our topic, we're going to talk about not only translation technology, but also machine learning. So it goes without saying that machine learning has played a very important role in the overall development of translation technology over the past 2 decades, I'd say. So we've seen some exciting developments in the field of translation technology, and machine learning is definitely a very important driver behind that. So you can see that we have some useful applications with better quality, especially in the case of machine translation or automatic translation. You can see that we have more powerful translation engines nowadays with higher accuracy, and also in terms of readability, in terms of the translation quality. And of course, there are different ways for you to build translation applications. And of course, one of the approaches is machine learning. And machine learning is a very useful tool that helps us think about how we can design our tools and implement different new features so as to enhance the quality of translation technology as a whole. So just imagine that machine translation 20 years ago, while the translation quality was probably a little bit low in terms of accuracy, in terms of the overall fluency. The translation given by the automatic translation engines 20 years ago would not be really readable, and that could be some problematic issues as well. But nowadays we have much better translation in terms of fluency and accuracy. And of course, in addition to machine translation, there are many other new kinds of translation applications, very attractive, very appealing, very useful for translators. So for example, in the past, we tended to have very simple grammar checkers or spell checkers, and probably they offered rather limited suggestions to translators. So nowadays, given the fact that we have more powerful machine learning algorithms, more powerful features could be implemented, and more useful suggestions could be offered to translators when it comes to, for example, editing kind of useful suggestions on how the text could be, the type text could be revised. So more flexible options could be offered, and all these exciting developments, whether we're talking about machine translation or spell checking or grammar checking, all these are due to kind of advancement in the world of machine learning, especially like deep learning. We're going to talk about that in great detail over the past few years. And so this is why we like to put equal emphasis on machine learning and translation technology in this short talk. And of course, when it comes to translation technology, there are different interesting topics we can explore. For example, we can talk about tool selection, we can talk about tool operation. We have many sophisticated translation applications like translation memories and terminology databases. And then of course, we can talk about tool evaluation as well. And here we'd like to focus on machine learning. We would like to talk about some useful and important machine learning methods that have already facilitated the development of translation technology. We would like to talk about something behind the scenes. We would like to see how different features could come into existence, could be implemented, could be realized with the adoption of appropriate machine learning methods. Okay, so we can so don't worry, we're not going to talk about kind of mathematical and programming details of machine learning. I understand that probably you might be more interested in kind of high-level description of how machine learning could contribute to the overall development of translation technology. So then you don't need to worry about mathematics and programming here. High-level overview will be given. Okay, so my outline the outline of my talk today is as follows. First of all, I'd like to give you an overview of machine learning first. For example, I'm sure that you're very familiar with artificial intelligence, and we'd like to have an overview of like the interaction or the relationship between artificial intelligence, AI, and machine learning. And in addition to that, we'd like to talk about some important features you probably want to pay attention to when it comes to machine learning, some important features, and also we'd like to highlight some important tasks in the world of machine learning. So there are a few important tasks we need to do in order to build an application that is based on machine learning. So this is part one of my talk. And the second part, we would like to further explore the world of machine learning with a focus on its application with translation technology. So we would like to, if we have time, we would like to talk about two important algorithms that are related to the development of machine translation to see how machine learning can contribute to the development or advancement of translation technology. Just two simple examples. And then after that, we'd like to highlight some important directions that you probably want to pay attention to with regard to the way forward. So we'd like to highlight some important areas and goals that probably could contribute to further or sustainable development of translation technology with regard to the adoption of machine learning approaches. So this is the basic outline of my talk. Let's take a look at part one. Discuss part one here, an overview of machine learning. And so again, as I just mentioned, probably you're very familiar with artificial intelligence, and artificial intelligence has become part of our daily life, actually. So we have different AI applications nowadays, but actually when it comes to artificial intelligence, the basic idea is very simple. It's just about how we can build smart engines or teach the computer to complete tasks in a way that we human, not only human translators, but also different professionals do. Okay, so that's kind of artificial intelligence. So probably want to build a smart engine that can read a text, that can understand text, that can generate text, and so on. But of course, more specifically speaking, probably there are some more exciting applications you've noticed before, in addition to language and translation. So you can see a couple examples here. So the first example here is about object detection. So we have an image, for example, and then the computer or the AI engine is smart enough to identify different objects in the image. You can see that we have bottle, we have glass, we have chair, handbag, and so on. So this kind of object detection, and it is a very useful application in different scenarios. And the second one is about time series forecasting. Time series forecasting, for example, a very simple and perhaps exciting example is stock price prediction. We have kind of past data, and then we want to build a smart engine, an AI engine that can predict future values with reference to the data in the past. This kind of time series forecasting. And the third one, we have AlphaGo. This needs no introduction, very famous application or kind of invention, outperforming human chess players a couple of years ago. So of course, AlphaGo and perhaps in the world of AI, I mean, entertainment and probably game design, and AI has been playing a very important role. And of course, we have some additional examples here. The next one is automated driving. So of course, computer-aided driving is very common nowadays. So for example, the use of kind of a mobile application for navigation, for example, if not familiar with how to get the place, and probably kind of Google Map or similar applications can be very useful. And then of course we want to have kind of more more advancement in the field of driving. And of course, automated driving is one of the most exciting areas you want to pay attention to. But of course, this is, automated driving could be very complicated given the complexity in terms of the road condition, and also the capability of responding to different situations that could take place. And then this is another fascinating area of artificial intelligence. And of course, image classification is another important example. For example, so you can see that it's somehow similar to object detection, but here we have different images, and then we want to build an AI engine that can classify them. They could, classify images into different types, for example, cats and dogs and other objects. And of course, robotics here, like a kind of sophisticated control of the movement of a robot for some important tasks. So for example, in the case of emergency, sometimes we might want to deploy a robot to some complex situations. Probably such a situation might be a little bit dangerous for human to get involved, and then robotics could be really important. And again, somehow similar to automated driving, this involves the detection of changes in the environment, and also you need to kind of make quick responses in the light of the changing environment. And then again, AI does play a very important role in terms of the implementation of such functionality. Okay, so we've already considered different examples of artificial intelligence in addition to language and translation. And more specifically speaking, there are different ways for you to build AI. And you can see on the screen, there are two basic approaches. The first one is called symbolic AI. So symbolic AI is a very, I say, it might be a little bit intuitive here, not really difficult to understand, but when it comes to real world implementation, it could be really challenging. So symbolic AI involves the design of rules and also the manipulation of different symbols in order to complete different tasks, no matter we're talking about image classification or machine translation or other language related tasks. So we would like to design different types of rules to tell the computer how to complete different tasks. And of course, the application of different rules it's about like the manipulation of different symbols representing our input values and perhaps the intermediate results and so on. At first sight, it sounds intuitive, but when it comes to the development of real world applications, this could be challenging, although, well, symbolic AI has a very long history. And if you consider the design of rules, probably you need to recruit a large team of experts in order to design such rules, in order to like make observations of the real world situation and derive rules accordingly. So that could be time consuming and that could be expensive. And the second issue with regard to the design of rules is it might be rather difficult for us to capture all the possibilities by just using rules, because the world is so complex, especially in the case of translation and perhaps automated driving as well. It's rather difficult for us to have kind of really comprehensive observations in order to have a comprehensive set of rules that can capture all the possible scenarios. And in addition to that, given the fact that language keeps changing when it comes to the development of language applications, it's also very important for us to revise our rules regularly in order to reflect the latest linguistic and cultural changes, so that the computer can handle kind of new ways to use language properly. And again, that requires additional time and resources. And of course, even though you are able to derive a comprehensive set of rules for relatively simple applications, you need to consider many other issues while implementing such rules. For example, it's not uncommon for us to have cases in which we have multiple rules that are equally or seemingly equally applicable to a particular input situation, and then probably you need to have another set of rules telling a computer how to make appropriate decisions when possible, when there are multiple rules that are possible for particular situations. So you have rule conflict and so on. So you can see that there are many issues when it comes to symbolic AI, and that's why researchers are also very interested in the second approach, that is the scope, I mean, our focus today, that is machine learning. So instead of building engines that are based on handcrafted rules, we like to build engines that can learn from data on the Seng. Okay, and this is a very attractive point of machine learning. So we no longer need to have many rules. We don't need to design different rules. And what we need to do is to build an engine that can learn from data. So instead of providing the computer with rules, we just need to provide the machine with a lot of data, and the computer can extract patterns and perhaps features that can facilitate the completion of a particular task after the training process. So you can see that training is important. We need to provide the computer with data, and then the computer can learn from the data provided in order to extract patterns for the completion of a particular task. So you can see the goal of machine learning is a little bit different from the goal of symbolic AI. The first one, we want to focus on rule design and implementation, and then the second one is about the development of an engine that can learn on its own. Okay, so this can be very useful when it comes to like the development of language applications or translation applications. When we have new ways to use language, we have new ways to interpret an expression or to use an expression. Probably you just need to update your data instead of asking a large team of experts to derive new rules for that, and then the new rules might have kind of conflict with the the existing rules in the platform, and then that could be really problematic. Okay, so more specifically speaking, for machine learning, there are a few important tasks you might want to pay special attention to, or in other words, we have a few key stages. Of course, in order to build a machine learning driven application, you need to have data first. We are talking about data, learning from data. So we need to have a collection of data. You need to collect data. And then of course you need to, in the world of machine learning, it's important for you to consider like the quality of your data and also quantity of data, because if your data is not good enough, and probably the machine, your machine can hardly learn something meaningful from the low quality data you have, and then probably you want to avoid that. So imagine that you just want to build a machine translation engine based on bilingual data. If the bilingual data there may be some problems with the bilingual data, and then your machine translation could also be problematic in that case. So this is not an ideal situation. And of course quantity is also important. So we have the concept big data, especially when it comes to deep learning. We're going to talk about that later. You probably want to have a large amount of data in order to help your machine learn something really meaningful, because sometimes if your data set is too small, it might be rather difficult for the computer to extract something meaningful from your mini data set, and then that could lead to problems in terms of the quality of your engine. The data collection. And then the second part is model development. As I mentioned, for symbolic AI, you need to design rules. For machine learning, you need to have a good mechanism telling the computer how to learn from the data provided by you. It is just about how to learn. You want to specify how the machine can learn. And that's another fascinating topic. There are so many ways for you to build your model that can learn from data. There are different approaches, and we're going to talk about two of them here for translation technology in the second part of our presentation here. And then the third part, after your model is ready, you want to have training, so the actual process of so-called learning. The computer try to learn from data. More specifically, it's about like extraction of patterns or features relevant to completion of a particular task, more rather talking about speech recognition or like translation and so on. So the second part, this stage is about training the actual learning process. And then after that, we need to determine whether the training is good enough, or whether we need to have further rounds of training, or whether we need to have kind of modification with regard to the internal design of your model. And then this is about evaluation. And so probably you want to have another data set, giving the computer or your model data that have not been seen before, so that the computer is kind of unseen data, in other words, so that the computer, so as to evaluate whether the machine is really learning something from the data provided, or whether the computer or your model can apply what it has learned to some unseen situations. So this is also very important task, evaluation. So of course there are different ways to do evaluation. We can have kind of human evaluation, but of course in the world of machine learning, we want to have kind of automated evaluation. The computer can have kind of self-evaluation during the process of training, for example, or after the completion of training. So but the key point here I'd like to highlight is we want to use unseen data. The data for evaluation shouldn't be used for the training part, so that we want to know whether the computer is really learning something having the ability to generalize the features or patterns extracted during the training process. And then after that, it's ready for deployment. Users can provide their own data to make prediction, to get machine translation output and so on. But of course, even after deployment, we want to have continuous improvement. We of course can collect data from our users, collect feedback from our users to see how we can further enhance the quality of our model, and if possible, we might also want to include some new features that can enhance the user's experience as well. So these are the 5 key stages of machine learning, and probably I hope that after this introductory part of the talk, this can help you develop a better understanding of what machine learning is and some key tasks involved in the process. Okay, and the second part, I'd like to discuss 2 machine learning approaches to translation technology. So we would like to see how machine learning can contribute to the development of new applications or contribute to the enhancement of translation technology. So of course, when it comes to translation technology, there are many exciting applications we can consider. We can talk about machine translation, we can talk about translation memory databases, we can talk about terminology databases, and many other fascinating applications. But here, given time constraint, I'd like to focus on machine translation. So machine translation is arguably one of the most popular translation applications. It's popular among translators and also non-translators. And so machine translation can be in different forms. For example, we have many exciting and very useful online translation platforms like Google Translate and so on. And then we have applications as well, mobile applications, especially useful for travelers visiting foreign countries. They want to have kind of informal communication with local people there, and if they don't speak the language there, and then the mobile application can be really useful. And I would like to say that the popularity of machine translation is probably due to the fact that it's simple use, right? So unlike other applications like translation memory databases, probably you need to consider different steps in terms of operation. You need to have alignment, and you need to import your TM and so on. Rather complicated, but for machine translation, you can just type your source text, or you can talk your phone, you take a picture of the source text, and the computer can identify the content and generate the translation almost immediately. So it's very simple from the user's perspective. And I like to say that machine translation is a very interesting form of translation technology in the sense that it is very simple, and at the same time, it is really complex. It depends on whether they're talking about machine translation from a user's perspective or from the perspective of engineering or artificial intelligence. It's rather difficult for us to teach the machine to do translation, especially for earlier algorithms and engines. It would be rather difficult for the machine to really understand the source text. And then we need to be really creative in order to see if there are ways for the computer to handle the input text in a way that is smart enough, that is good enough for the generation of the target. It's not only the generation of the target, but also the analysis of the source text. So you can see the very complicated issues here. And that's why we had our first machine translation engines like 70 years ago. And nowadays, so that we have some, significant progress in many other fields of artificial intelligence, for example, image classification or object detection. But for machine translation, it's rather hard for us to build an engine that can outperform human translators because of the complexity of linguistic and cultural issues. And even the state-of-the-art machine translation engines we have nowadays, they are not perfect. There's still much room for improvement. Okay, so and that's why I want to talk about machine translation. It's so fascinating. It's so interesting. It's very simple at the same time. It's really complicated. Okay, so when we talk about the design of automatic translation engines like Google Translate or similar applications, of course, there are different approaches available. And then recall what we discussed earlier today, you want to consider the use of symbolic AI or machine learning. So it goes without saying that one of the very important approaches to the development of machine translation engines is the use of rule-based approaches. So rule-based MT, that involves the use of linguistic rules for source text analysis and on one hand, and target text generation on the other. And so for rule-based MT, and of course, when you consider early machine translation engines, you can see that rule-based machine translation approach was the mainstream like 2 or 3 decades ago, for example, if you consider machine translation engines developed that time. And more specifically speaking, there are different forms of rule-based MT when it comes to symbolic AI. For example, suppose we have a source text comprising 3 words, and then we have something called direct MT. We want to have word-for-word translation first, and then after that, you want to have kind of reordering in order to make sure that the word order is natural in the target text. And so you can see that you need to have 2 sets of rules. The first one is about word-for-word translation. You need to tell the computer how individual words can be translated into target language. And then after that, we probably need to implement another set of rules telling the computer how to have kind of reordering. So 2 sets of rules. Of course, this is kind of simplified version of direct MT or rule-based MT here, but I just want to to give a simple example to let you have a basic idea what it is. Okay, and then sometimes probably for more sophisticated rule-based machine translation engines, we want to have more in-depth analysis of the internal world of your input text or input sentence, for example. So for example, we want to have kind of part of speech analysis, POS analysis. We want to have syntax. You want to pass kind of syntactic elements, syntactic trees, and so on. So we want to have more in-depth analysis, and then we have kind of a syntax tree and the source text, and then you want to convert it to its counterpart in the target language, and with reference to the syntactic tree here, in the target language, you generate the target text. We have something called transfer MT. That was also very popular quite a few years ago. And then, so some researchers might want to, they attempted to have more in-depth analysis in addition to lexical analysis and syntactic analysis, as in the case of transfer MT and for interlingual MT. So in other words, we want to have, so of course, let's go back to transfer MT here. So you need to have different sets of rules for the generation of the syntactic trees and the generation of the target text in the process. So the last one, like interlingual MT, we want to have not only lexical and syntactic analysis, we want to have semantic analysis as well. Again, using rules, we want to have kind of in language independent representation. So no matter whether you have Chinese, English, French, Japanese, German, you want to have a unified internal representation that captures all the subtle features of different languages. And then based on that language independent representation, again, that is generated through the use of different rules. And then you want to make good use of like this internal representation to generate the target text. So and this interlingual MT is probably very appealing, because when you consider transfer MT, you want to have multilingual support. For example, you want to have you want to develop translation engines that can translate between Chinese and English. Of course, that's straightforward, but when it comes to multilingual support, like English, Chinese, French, Japanese, and German, 5 languages, and probably you need to develop 20 engines, 5 times 4, 20 transport engines in order to achieve the goal. But when it comes to internal representation, so we just need to have 5 engines for the translation of Chinese, English, French, Japanese, and German to the intersemiotic. I mean, not intersemiotic, the interlingua here, kind of language independent representation. And then you just need to have another, 5 more engines for the generation of the internal, for the generation of the type test from the internal representation. So really appealing at first sight, but again, in terms of implementation, it could be really challenging. So it's not really difficult for us to build rules for basic lexical and perhaps syntactic analysis. But when it comes to ways to design rules to generate kind of language independent representation. So the first question is that how can you design relevant symbols for the representation of all the possible linguistic features in different languages? So this is point number 1. And point number 2, even though it might be possible for us to have this kind of representation when we have kind of very restricted domain, I don't know, probably like the translation of very report, probably that's possible. But how can you derive rules to extract all the subtle features and convert them to kind of language independent representation? Again, it's a very challenging task, and that's why even like when you consider engines many years ago, even though they adopted kind of rule-based approach, many of them many of them were actually transfer empty rather than interlinear empty. So it's theoretically appealing, but when it comes to real-world implementation, many challenges. So, but what about our machine learning driven approach? And then probably I'd like to highlight 2 very popular approaches, and they are statistical machine translation. The first one I like to highlight, and then the second one, neural machine translation. Okay, so we have rule-based machine translation, RBMT in short. That was symbolic AI. And then when it comes to machine learning approaches, you might want to pay attention to statistical machine translation and neural machine translation, or SMT and NMT in short, respectively. So should we take a look at the first one, statistical machine translation? So the basic idea of statistical machine translation is pretty simple. We just want to find a sentence or a combination of target language expressions that's most likely to be the correct one, to be the correct translation, to be the best translation, if you like. So the one that is most likely to be the best one. So you can see the key phrase here, most likely, and then and you can see another keyword here, statistical. So it's just about the computation of probabilities. So I think that probability is nothing new to you, and then probability is one of the very important topics in high school mathematics. Like, for example, if you're given a bag of balls and there are 3 red balls and 2 blue balls, what's the probability of having a blue ball, something like that? But here in the world of machine translation, we want to focus on the probability of translation and the probability of sentences, in order to find the one that is most likely to be the correct one. Okay, and more specifically speaking, there are 2 stages. First of all, we have the source text, and then for statistical MT, we want to have a translation model, computing the probability of different expressions to see if there are any useful expressions that can be used in the target text. So it is about translation model. And then we have another step that is language model. Language model, we want to, so after translation model, we have a list of possible candidates that be used in the target language. And then and we want to see how to rearrange and recombine them in order to generate the target text. So you can see that we have 2 models here. Of course, this is a very simple example in statistical machine translation was actually first put forward in the late 1980s and early 1990s. And if you've read papers on statistical machine translation before, probably IBM models 1 to 5, nothing new to you. And later we had kind of phrase-based MT, like focusing on the translation of groups of words rather than individual words, and that was a very popular approach in the 2000s, and also in the first half of 2010s, and of course we nowadays we have some new approaches and new machine translation. For example, but for statistical machine translation, its popularity in the 2000s and in the early 2010s was kind of strong evidence showing the effectiveness and efficiency of this approach, and probably outperforming its predecessors like rule-based MT. And more specifically speaking, if we want to build a translation model, the identification of useful expressions in the target language for the recombination of them using a language model. For translation model, we often need to have a bilingual corpus. We want to have bilingual text, and of course, in order to train this model. And then for language model, we need to have a monolingual corpus for the training process. So you can see this is somehow similar to kind of direct MT. We want to have word-for-word translation first, and then after that, we have kind of reordering. So more specifically speaking, we have our corpus. The first one, bilingual corpus, and then we have the second corpus, we have kind of monolingual corpus. So bilingual corpus is basically for the generation of a bilingual table. So we want to have, for example, sentences in the source language and also sentences in the target language, and we want to divide the sentences into words or phrases. Depends on whether you're talking about word-based translation or phrase-based translation. And after that, you have kind of alignment. You want to see the connection between individual words and phrases in the source language and target language. You have kind of alignment. You want to calculate the probability. We have a conditional probability here. I promised I'm going to talk about mathematics today. Just a very simple mathematical expression. You can see conditional probability here, like given the target text here, what is the probability of a source language expression? That expression is the source text over the target text. You can see a table here, something that after training, we have a bilingual table. For example, we have the word "ngor" here, and then we want to see, given the word "ngor," the probability of the source text I is the source text is 0.7 and so on. So by making use of this bilingual table, we are in a position to identify relevant expressions that can be used in the target language for the second stage of our processing here. So here for the second stage, for the development of our language model, we need to have a monolingual corpus here, and obviously want to build a monolingual table for the calculation of the probability of a sentence in the target language. So you can see that we have kind of conditional probability here, and then we have PT. And if you're familiar with the Bayes theorem, and you can put together. Of course, there are different ways for you to combine the two probabilities here, and to have a finalized score to tell how likely that a particular sentence is the correct translation. But anyway, so this is a very simple example of a monolingual table here. And again, we have kind of phrase-based approach. So the concept phrase in the world of statistical machine translation is different from linguistics. We have a pretty loose definition of phrase here. We just consider phrases to be groups of words, and that's it. Okay, so the delineation of phrases is a little bit arbitrary in the case of statistical machine translation. It depends on the nature of your data, after all. Okay, and so this is what we have after the use of bilingual corpus. You have a bilingual table, and then for monolingual corpus, you have monolingual tables. This is kind of the output of our training. And here I like to use this very simple sentence, very popular the internet in Hong Kong a couple of years ago. I'd like to show you how this sentence could be translated by adopting the statistical approach through the computation of different kinds of probabilities. So I go to Dubai by bus, and the first stage, we want to have translation model first. Okay, as I mentioned before, so first of all, you need to divide your source text into individual expressions. So we have words or phrases here. We have I, go to school, buy, bus. So again, we just adopt the very broad definition of phrases in the world of statistical machine translation, referring them to be groups of words. And then after that, we want to have phrase by phrase translation or unit by unit translation. But here, a very important difference I'd like to highlight here, instead of using a handcrafted dictionary telling you how, or a set of rules telling you how to translate individual phrases into entire language, we want to use our bilingual table, the probabilities. For example, for I here, there could be different probabilities like 我本人 and so on, with different values, of course, depending on the data provided by your, by the developer. And then we have probably the computer wants to select the one with the highest score. And of course, there are exceptional cases, and that goes beyond the scope of this talk today. So just select one of them. And we have I go to school, and then we have Seng. And then again, you refer to a bilingual table to see the most likely expressions. And then for buy, we have different verbs possible, perhaps. And then we have 坐, and then bus here, 公交车. And of course, bus is more common in Hong Kong. And again, the probabilities here actually depend on the data, how you collect your data. For example, if you have more articles or documents from publishers in mainland China, probably it's more likely that you have 0.4 here. But if you consider the collection of documents from other sources, for example, government documents in Hong Kong, and probably the BASI might be more common, and then you have different results. So this is exactly why, as I mentioned before, it's important for you to consider the quality and quantity of your data in order to have kind of meaningful representative learning, or useful learning, or the extraction of representative features from the data, the process of learning, in order to make sure that your results are acceptable. So that's about data. And then for full stop here, and then probably we have this Chinese punctuation. Sometimes it refers to decimal point, and then we have different values, and then we have kind of rough translation here, phrase by phrase translation, and that is stage 1. And for stage 2, for language model, and probably there are different ways for you to recombine or to combine or recombine the expressions generated in stage 1. And of course, if you have longer sentences, there are more possibilities. And of course, we need to have a good way to reduce the number of possible candidates for evaluation. So here for language model, to make things simple, I just want to propose 2 options. We have 我想學坐公交車. And then we have the second one, 我坐公交車上學. So just imagine that we have only 2 possible candidates here. Of course, there are different ways we arrange the 5 candidates here. Some of them are more probable, some of them are not really possible. But anyway, just consider these 2. And after that, you want to have a monolingual table. As I mentioned, you want to use a monolingual table to compute the probability of a sentence, to see how likely that sentence is a valid one in the target language. So you can see that we have some dummy examples here, like for 我想學坐, the probability of this phrase is 0.1, and then for 想學坐公交車. So we want to calculate the probability of individual phrases or groups of words in the target language first, and then after they want to combine the probabilities into the sentence probability. So of course, again, the computation of the sentence probability, again, is beyond the scope of this talk, and probably you've already heard of something like n-grams, and you want to find the sentence probability using a language model with the help of the probability of individual n-grams. And there are different ways for you to put together different concepts in the world of language modeling. But even without the in-depth discussion of the computation of sentence probabilities, and by just taking a look at the monolingual table, you can see that 我想學坐，我想學坐公交車，坐公交車. These three expressions are more related to the first sentence, and then the last three expressions here are more related to the second option. And you can see that you can have kind of intuitive impression that for the first three phrases, probably the probabilities are lower, suggesting that even after recombination of the three probabilities here, that the overall score or the overall probability of that sentence should be relatively lower. But when it comes to, you can 0.1, 0.05, and 0.2, but of course, in reality, the numbers are much smaller, just for illustrative purpose here. And for the other three expressions here, like 0.2, 0.1, 0.1, they are higher compared with the first three candidates, and then it's more likely that we have a higher probability of this sentence, and then the computer just selects the one with higher probability, suggesting that it is more likely to be the correct translation. Okay, so you can see that again, although we have something like phrase to phrase translation and also reordering, we don't need to apply any handcrafted rules. What we need to have is table, a bilingual table and monolingual table, and these two tables are generated with the use of machine learning or data training or model training. The computer can extract such information from the data automatically. So this is a significant difference between rule-based approaches to our statistical machine translation approach here. And I'd like to say a few words about the second approach to MT, that is neural machine translation. Well, it's become the mainstream of machine translation since like mid-2010s, like 2015 or 2016 or so. Well, neural machine translation is actually about deep learning, and deep learning is actually one of the approaches to machine learning. And as I mentioned at the beginning of this talk, in the world of machine learning, there are different ways for you to build engines that can learn automatically from data, and deep learning is one of the possibilities. And deep learning, or 深度學習, okay, 深度學習 here is about the use of artificial neurons. And of course, we have biological neurons, kind of basic unit of our brain, and then we want to do something similar, kind of loosely inspired by biological neurons. Scientists or researchers came up with the idea neurons a few decades ago, actually, but neurons has become popular recently because of the availability of like a large amount of data and also computing resources and so on. So neurons are very simple processing units, but when they are connected together, they can be very powerful. So this is point number one. And point number two, you can see that over the past few years or so, we've seen some very interesting applications in the world of artificial intelligence, and many of these achievements or exciting applications are due to the application of deep learning, actually. And a very important feature when it comes to deep learning is the fact that for other machine learning approaches, probably you need to tell the machine what features should be taken into consideration for the completion of a task. For example, image classification, you want to build an engine to classify images of dogs and images of cats, and probably for, of course, you need to have a large set of data for training, and in addition to that, you need to build an engine that can learn from the data you have. You need to consider, like, and for many machine learning approaches, you need to tell the computer, well, you need to pay attention to the eyes, to the nose, and to the ears, and so on. You need to specify what features should be paid attention to. And so you can see that that's still kind of human intervention or contribution there. And although we don't need to design rules, we need to specify what features are important. But this kind of manual specification of features might not be always accurate or relevant to that particular task. We might think that they're important, but in reality, they might not be really important, and we might have overlooked some important features that are important or critical to the completion of the task. So a very interesting feature with regard to neural machine translation is the fact that we don't need to specify what features are important manually. The computer, your neural network can, or network of neurons can automatically identify what features are important. So it is about automatic identification of useful features, very powerful. So probably exciting AI applications or AI-driven applications based on deep learning are so successful because of the fact that the computer identifies some features that are important for the completion of particular tasks that have been overlooked by scientists or researchers before. And then the computer can identify such important features automatically by itself. And then, of course, neural machine translation is a little bit demanding in terms of hardware and software. We need to have very powerful computers in order to have kind of training, the training of neurons or neural network. And also, you need to have sophisticated software to implement your idea, to implement your neural networks. But of course, scientists have been working very hard to identify ways to reduce hardware and software requirements. Okay, so it seems I'm running out of time, not in a position to discuss the details of neural machine translation. I'd like to show you this slide instead, giving you a basic idea of how neural machine translation works. So the idea is pretty similar to how human translators do complete their translation tasks. We have the source text and then we read the source text. Of course, this involves our intelligence, human intelligence, our brain, and then we have basic idea of what the source text is about. And then based on that idea, we consider how we can generate the target text. So we have analysis and generation, 2 steps. And similarly, for neural machine translation, again, we have the source text, and then the neurons or our artificial neural network, we have kind of an analysis in order to have kind of digital picture of the source text. Of course, using numbers here, computers love numbers. And then based on the numbers, we can have 50,000 to 100,000 numbers to represent the source text with an attempt to capture the features, including the meaning, the structure of the text. And then based on that artificial neural network, we have the generation of a target text. Based on the digital internal representation, the numbers we have representing the source text, another artificial neural network can generate a target text. Now, this is basically how neural machine translation works. And more technically speaking, we have kind of encoding and decoding, and the first neural network is called encoder, and the second one is called decoder. Okay, I'm afraid I can't discuss the details of the design of artificial neural networks and, for example, how neurons are organized, combined in order to form a neural network. And basically speaking, for neural machine translation, there are 2 ways for you to, at least 2 ways, there are actually many, to design your network and in order to do translation. And I'm afraid I'm not in position to discuss them. Let's jump to our last slide. I'd like to talk about our topic 3, not topic 3, our part 3. I'm going to skip all these slides. Okay, so the way forward. So very quick conclusion, give me 1 more minute here. Okay, so looking ahead, probably want to pay attention. I mean, scientists and researchers might want to see. So again, machine learning is all about training, data collection, data training, model training, and also evaluation, and probably want to have more training data. You want to have kind of innovative model architecture. We mentioned statistical machine translation and neural machine translation, and even in the world of neural machine translation, there are many possibilities. So model architectures, kind of innovation is another important factor. So training methods, so we want to have innovative training methods so as to help the computer identify features and useful information and patterns more effectively and efficiently in the process of training. And then for decoding method, that is about the generation of text. We didn't mention that. And then evaluation methods, we want to have more sophisticated mechanism to have kind of automatic evaluation that can truly reflect the actual performance of our translation engines. And then with the following goals, we want to increase the quality in terms of readability and accuracy, and we want to reduce our training time. In the past, probably it took days or weeks in order to complete the training process when it comes to neural machine translation. We want to reduce that. And the third one, we want to reduce computing requirements. As I mentioned, for deep learning, probably we need to have very powerful computing in order to train such models, and it might be very useful for us to reduce computing requirements in order to popularize the training of such models. And then wanting to increase translation speed is important, of course. So for some engines, if you don't have a powerful computer, it could take a few seconds to have translation, but this is not good. We want to have kind of almost simultaneous translation, and we want to have language support, not only major languages but also other languages that are also very important to us. And then we want to explore new modes of translation, speech translation, and probably the processing of images as well. Okay, so I think I'm going to stop here. Thank you very much for your participation. That is at the end of my talk. Thank you.